Problem number 1. From the very first International Mathematical Olympiad, held in 1959, prove that the fraction 21n plus 4 over 14n plus 3 is irreducible for every natural number n. Before we dive in, let's make sure we understand the two key tools we'll need. First, what is the greatest common divisor? The GCD of two integers, a and b, is the largest integer that divides both of them. For example, look at the divisors of 12. That's 1, 2, 3, 4, 6, and 12. Now the divisors of 8, that's 1, 2, 4, and 8. The largest number appearing in both lists is 4, so the GCD of 12 and 8 is 4. On the other hand, 7 and 13 share no common factor other than 1. We call that coprime. There's one property of the GCD we'll need in particular. If D divides A and D divides B, then D also divides their difference a minus B. Keep that in mind. It's the engine of our proof. Now, what does irreducible mean? A fraction p over q is irreducible when the greatest common divisor of p and q equals 1. They share no common factor. 3 over 4 is irreducible. GCD of 3 and 4 is 1, but 6 over 9 is not. Their GCD is 3, so you can simplify it to 2/3. Now we state a key lemma. For any integers m and k, with k not 0, the GCD of m and km plus 1 always equals 1. In other words, the fraction m over km plus 1 is always irreducible for any values of m and k. Here is the proof. Let D be the GCD of m and km plus 1. We want to show D equals 1. Step 1. Since D divides m, it divides any multiple of m, so it divides km. Step 2. D divides km, and D also divides km plus 1, so by our key property, D must divide their difference, which is exactly 1. Step 3. If D divides 1, then D must equal 1. Therefore, the GCD is 1, and the lemma is proved. Now we apply it. We notice that 21n plus 4 over 14n plus 3 can be rewritten as the sum of 14n plus 3 and 7n plus 1, all over 14n plus 3, which simplifies to 1 plus 7n plus 1 over 14n plus 3. So it suffices to prove that this smaller fraction, 7n plus 1 over 14n plus 3, is irreducible. Now look at the denominator. 14n plus 3 is exactly 2 times 7n plus 1 plus 1. So our fraction becomes 7n plus 1 over 2 times 7n plus 1 plus 1. That is precisely the form from our lemma, with m equal to 7n plus 1 and k equal to 2. By the lemma, their GCD is 1. Therefore, the original fraction 21n plus 4 over 14n plus 3 is irreducible for every natural number n.